Hello friends, welcome to this exercise on how to perform series and parallel operations on two single-phase transformers. At the end of this video, you will be able to conduct the polarity test of the transformer, connect two single-phase transformers in parallel, connect two single-phase secondary transformers in series.
Let us discuss polarity in transformers. Polarity refers to the direction of the induced voltages in the transformer's primary and secondary windings. Knowing the polarity is necessary for the proper connection of the transformer if the two transformers are connected in parallel. Necessity of paralleling two single-phase transformers. First, when the power demand of the load increases, two or more transformers may be operated in parallel. Second, when the power demand decreases, only the required number of transformers may be operated with their full load capacity, whereas the remaining transformers may be switched off and taken for general maintenance or service. Third, the efficiency and life of the transformers increase and the losses are reduced. Fourth, it provides more reliability of power, that is, even if one transformer fails or becomes out of service, other transformers will supply a certain amount of load. Fifth, it is not economical to manufacture a single very large capacity transformer. Thus, operating two or more optimal capacity transformer in parallel is more economical. Sixth, it is easy to plan the maintenance schedule for the transformers, which reduces the cost of maintenance and spares. Conduct the polarity test of the transformer. Identify the LT and HT terminals in the given transformer using an ohm meter or multimeter. Connect the DC supply to the HT through a push button switch and connect voltmeter to the LT as shown in the circuit diagram. Mark HT terminals as A1 and A2. Mark LT terminals as A1 and A2. Press the push button switch. Observe the deflection of the pointer of the voltmeter on the LT side. If the pointer deflects in the right direction, retain the markings made on the terminals. Change the voltmeter connections made to LT terminals and change the markings made on the LT terminals if the deflection is in the reverse direction. Now press the push button switch once again and observe that voltmeter deflects in the right direction. Connect the transformer secondary in series. The polarities of the secondary of both transformers should be connected properly, the same as a series connection, to get the voltage added. Otherwise, the output voltage will be zero. As the output voltage is double of the individual secondary voltages, care should be taken to ascertain the insulation level of the secondary windings. Take two transformers, transformer 1 and transformer 2, that have to be connected in series. Identify the LT and HT terminals by measuring resistance using an ohm meter or multimeter. Check for polarity in both the transformers and mark A1 and A2 at the primary side and A1 and A2 at the secondary side. Connect the primary of both transformers, transformer 1 and transformer 2, to the input supply as shown in the circuit diagram. Connect the A2 terminals of the secondary transformer 1 in series with the A1 terminals of the secondary transformer 2 as shown. The output voltage of the series connected transformer is measured across the A1 and A2 terminals of transformer 1 and transformer 2 respectively. In a series circuit, the current rating will remain the same and voltages are additive. The output voltage measured using a voltmeter shows 230 volts since both the secondary circuits have 115 volts. Close the switches S1, S2 and S3. Measure the primary voltage V1 and secondary voltage V2 and record them in the table. Ensure the transformation ratio is the same. Disconnect the transformers by opening S3, S2 and S1. Connect the transformer in parallel. Conditions to connect the two single-phase transformers in parallel. The voltage ratio must be the same. The input voltage must be the same per unit or percentage impedance, same polarities of both transformers. Read and record the nameplate details of both the transformers, transformer 1 and 2, in the table. Determine the polarity of the two given transformers. Connect the switches, transformers and meters as per the diagram. Connect the A1 and A2 primary sides of the transformers TR1 and TR2 to the 240 volt 50 Hz AC supply through the switches S2 and S3 respectively. And connect the A1 and A2 secondary sides of both transformers TR1 and TR2 to the output terminals. Keep all the switches open. Ensure that the transformers are identical for parallel connections. Connect transformer TR1 to the bus bar, closing the switches S1 and S2. Measure the primary voltage V1 and record it in the table. Close the switches S3, primary voltage of the transformer TR2 and record it. Close the switches S4 and S5. Measure the secondary bus bar voltage and record it. In a parallel circuit, the current ratings are additive and the voltages remain the same. The output voltage measured using a voltmeter shows 115 volts since both secondary circuits have 115 volts. Switch off all the switches and disconnect both the transformers. Conclusion. The effect on the secondary voltage of transformers when connected in series is additive. The effect on secondary voltage of transformers when connected in parallel is the same.
I hope that after watching this video, you will be able to conduct the polarity test of the transformer, connect two single-phase transformers in parallel, connect two single-phase secondary transformers in series. This concludes the exercise on how to perform series and parallel operations of two single-phase transformers. Thank you. See you in the next exercise.